Okay, so normally for the questions related to conditional probability, I often draw a tree diagram. You don't have to, but I find it helpful for myself. What I'm having here is the result of the first tablet, whether the first tablet examined is defective or non-defective. And this is a result for the second tablet. This is a result for the third tablet. We start with each box contain 20 tablets, and we have a particular box containing 2 defective, which means it would have 18 non-defective. N standing for non-defective and D standing for defective. Initially, this is what we got. And we are interested in probability that the first tablet is defective or not. We have 2 defective and we have 20 tablet. So probability that a tablet is defective is 2 over 20. And for non-defective is 18 over 20. And the branch that we are dealing with here, it means conditional probability. For example, this one, then the branch means that probability that the second one is defective, given that the first one is defective. It does not mean probability that the second one is defective and first one is defective. This is a wrong interpretation. This is a correct interpretation. So just keep that in mind. We will fill in the number here. If our first tablet is defective, then we do not have 2 defective in the box anymore. We only have 1 defective. Then the chance that the second tablet is defective, given the first one is defective, is 1 divided by 1 plus 18 is 19. And probability of non-defective for the second one, given that first one is defective, is 18 divided by 19. We would do the same thing to fill in the number here. I will put back the initial number, 2 defective and 18 non-defective. If the first one is non-defective, then now in the box, you only have 17 non-defective left, but you still have 2 defective. Then probability of defective for the second tablet is 2 divided by 19. And non-defective is 17 over 19. We would do the same process to fill in all the number here. This branch means that what is the probability that the third one is defective, given that the first one is defective and the second one is defective. Initially, we have 2 defective and 18 non-defective. If the first one is defective and the second one is defective, then now we would have 0 defective left. Then probability that the third one is defective is 0 divided by 0 plus 18. And probability of non-defective is 18 over 18. We will move to this branch where we have 1 defective and 1 non-defective. Then probability that the third one is defective is 1 divided by 1 plus 17. So 1 over 18. And probability of non-defective would be 17 over 18. I do the same thing for this branch. And then the same thing for this branch, where you have non-defective and non-defective. Any question about the tree diagram here? You will see a tree diagram like this become helpful when you are dealing with problem of picking the ball with or without replacement. So the first question is, we are interested in probability that two defectives, one, are found in the first three tablets examined. You will realize that each of the paths here represent for one possible outcome when you examine three tablets. So these represent for the first one is defective, the second one is defective, and the third one is non-defective. We are interested in those outcomes such that there are two defectives. This would be the first one. This would be the second one. Because we have one defective here and one defective here. And this would be the third one. In order to calculate the probability that there are two defectives, we just need to add probability for each of the case together. We are having three cases here. We will add probability of defective, defective, and non-defective. D and N and D. Non-defective, defective, and defective. For each of the number here, what you will do is you will look at each path, D, D, and N. You will calculate each number here and multiply them together. In terms of notation, you will have probability of D, D, and N is that getting the first one defective multiply with second one is defective, given that the first one is defective, and third one is non-defective, given that the first two is defective. In the exam, we expect you to write down this notation in order to calculate each of the term here. But in the tutorial, I will use a bit shortcut. I will not write down the notation, but rather I will just write down the number. So if we look at this way, probability of first one is defective correspond to this number. D2 given D1 correspond to this number. N3 given D1, D2 correspond to this number. Which means for each path, you just need to multiply all the number on the branch together. And then we have defective, non-defective, and defective, which means this one here. Non-defective, defective, and defective. And if you add everything together, it will be the answer that you're looking for part one. I will remove the highlight for part one. Okay, for part two, we are interested in third tablet is defective. So we will just look for a path such that the third one is defective. First, we got this one here. Next is this one, and this one. You will calculate the probability of each path and then adding them together. So the first part here is 2/20, 1/19, 0/18. Again, in the exam, we do expect you to write out the notation so that we know what you are writing. In case that you do something wrong, but you tell us like the process where you got to the answer, then you will still be able to get part mark for that. The second path is this one here, 2/20, 18/19. What number is that? I think 1/18. The third part is here. One thing when you create the tree diagram is that you have to notice at each branch, all the probability adding together have to be equal to 1. So 2/20 plus 18/20 is 1. 1/18 plus 17/18 is equal to 1. Unless you intentionally not writing down, but if you write out all possible outcome for each branch, it should add up to 1. If it doesn't, then it means that you created wrong tree diagram. The third one is we want to know probability that the third tablet is the second one that is found defective. You will see that is the path here because we already have one defective before the third one. And then the path here because you have a defective here. And then the third one would be the second one that is defective. So probability of this path is 2/20, 18/19, 1/18. This path is 18/20, 2/19, and 1/18. If you add them together, you will get the answer for part 3. Any question about this one? Let me know if you have any question. If not, then I will let you attempt question 3. Again, 5 minutes. I suggest you to draw a tree diagram. What is the ball? What is the ball that you got from the first ball? And then what is the color of the ball that you got from the second ball? And what is the probability for each case? Okay, so first I also draw a tree diagram. The first column show me what color of the ball I got when I select randomly a ball from the first ball. And this column represents for the color of the ball that we choose from the second ball. We start with 6 white and 5 red from the first ball, which means probability that you can pick a white ball is 6/11, because in total you have 6 plus 5 balls, which is 11. And the number that you're supposed to fill in here is probability that you select a white ball from the second ball, given that you select a white ball from the first ball. Let's assume that we select a white ball from the first ball. Then now, in the first ball, we only have 5 white left. And it says that we select a ball from the first ball and place in the second ball, which means we transfer the white ball from the first ball to the second ball. Now the second ball would have 4 white. And then you choose a ball randomly from the second ball. Then probability that you got a white ball is 4 divided by 11, because now you have 4 plus 7 is 11 balls in total. And probability that you get red ball from the second ball is 7/11. Now let's go back to the beginning, where you have 6 white here and 3 white here. We are dealing with a case where you got red from the first ball. Then now, from the first ball, you only have 4 red left. And you transfer that red ball to the second ball. So it is 8 red here. Then when you choose a random ball from the second ball, you would have 3/11. And probability of red from the second ball is 8/11. The question is asking us what is the probability that a second ball, like the ball from the second ball that we selected, is red. If we look at the tree diagram, there are only 2 parts that give us red 2. First is this one here. And second is this one here. In the exam, what you should write down is, I will take probability of this plus probability of this. The first part is you get white from the first ball and red from the second ball. The second path is you get red from the first ball and you also get red from the second ball. You know that in order to calculate this quantity, you just take all the number on the way and multiply them together. But in terms of notation, what does that mean? The number here represent for probability that you get a white ball from the first ball. The number here represent for probability that you get red from the second ball, given that you get white from the first. We do the same thing with this one. We want to multiply 2 numbers together. First number means that probability that you get red from the first ball, and then you get red from the second ball, given that you get red from the first ball. And now you just need to plug the number in. And then you will use your calculator to calculate what is the final answer. Just plugging in calculator 6 times 7 over 11 squared plus 5 times 8 over 11 squared. And it should give you some probability between 0 and 1. Okay, I get someone have it here, 0.677. Are we good with this question, or is there anything confusing? I think all the questions that I chose for the tutorial today is the same difficulty as what you can get in the test. I didn't choose anything easier or more difficult than what you would actually get. If there is no question, I will let you work on question 4, maybe 5 minutes again. Let me know if you have any question in the chat. Okay, let's look at this again. It's really up to you, but I personally very like tree diagram for conditional probability problem. That's why you will always see me drawing it, but it's not requirement for sure. Here we start with 45% made no claim. So probability of no claim is 45%. And then 30% made one claim. And 20% made at least two claims. And then if during the previous year, which means if during this year, this is the result that the person filed a claim, then we will have the probability that the driver had 0, 1, or probability that a driver make more than one claim if each of the situation happen is 0.1, 0.3, and 0.6 respectively, which means that if the driver had made 0 claim in the previous year, then probability that the driver make more than one claim during this year will be 0.1. So more than one claim is 0.1, which means complement of more than one claim will be 0.9. Probability that the driver make more than one claim if they had one claims in the previous year is 0.3, which means more than one claim complement is 0.7. The last one I will have 0.6. Any question about my tree diagram? If not, then I will move on to answering the question. We are interested in finding the probability that a randomly selected driver will make at least two claims. At least two claims is the same as more than one claim during the following year. So the first column represents for the number of claims that the driver make this year. And the second column is the number of claims that the driver make during the following year. We are interested in probability that they make more than one claim during the following year. If we look at our tree diagram, this path here leads to more than one claim during the following year. Or this path also more than one claim during the following year. And then this path, we will have to calculate the probability of each path and then adding them together. We have probability of more than one claim during the following year is equal to, what does this path represent? It represents no claim during this year and more than one claim during the following year. And then this path represents one claim during this year and more than one claim during the following year. This path represents at least two claims this year and more than one claim during the following year. In order to calculate the first part, we will take this number multiplied with this number. In terms of notation, what does that mean? 45% is probability of zero claim this year. 0.1 is probability of more than one claim in the following year, given that zero claim this year. The number here is probability of one claim this year. This number means that probability of more than one claim in the following year, given one claim this year. Last one, we have probability of at least two claims this year and probability of more than one claim in the following year, given at least two claims this year. And now we can just plug in the number. 45% multiplied with 0.1, 35%, 0.3, 20%, and 0.6. And then you're adding them together. And the final result is what you expect to get. Any question about this part? You will see that the problem regarding conditional probability, even later in this week, we discuss about Bayes' theorem. It's just this idea. Is really nothing more complicated. It's just this idea. So drawing a tree diagram is a very useful tool in my opinion. And then figure out the probability in each branch correctly is also important. If there is no question, then I will end the tutorial here. Regarding to question 1, we didn't have time to go over it, but you can always check the recording for 20101. It's a pretty straightforward question. If you're confused about anything, feel free to post on Piazza.